This is a FarmDoc Daily webinar. I'm University of Illinois Extension's Todd Gleason, your host for the day. We're going to talk today with Gregory Bernard. He's at Tuskegee University in Alabama about some technology adoption in smallholder farms and bridging that gap. It should be a very interesting program, Gregory. I'm glad you're here with us. Can you first tell me just a little bit about yourself and what you do at Tuskegee University?
Yes, thank you. And thank you all so much for having me today. I am an associate professor at Tuskegee University, and I primarily work with molecular plant pathology. So I study plant disease and also plant biotechnology, developing ways of engineering plants, mainly for pest resistance. And so now I'm segueing into the incorporation of autonomous tools and robots towards precision agriculture and farming. And so finally, I do a lot of outreach and extension to help, as the webinar is entitled, to bridge the gap of new technologies to small scale and minority farmers.
And you work across a series of what I will call colleagues that are together in different universities, including the iFarm here on campus, along with the Center for Digital Ag and iRegen, and then within a couple of other places too, the AI farms, and sometimes with those things that we have talked about in the past here, like EarthSense, which is a company based in the research facilities on campus at the U of I. I am interested to know what kind of things we'll be talking about today. Can you kick off the webinar for me, please?
Thank you. No problem. And yes, I'm very excited to collaborate with our partners at Illinois. We have a lot of fruitful research together. So just to get things started, why do we need to expose farmers, minority and small scale farmers, to these technologies? Well, we want to help them with their production strategies. And the incorporation of autonomous tools such as robots, unmanned aerial vehicles, and other technologies that I'll talk about today becomes very important for not only bringing the awareness of these new technologies to the farmers, but in hopes that they will adopt these technologies and help make their farming practices more productive. And so precision becomes very important. Using tools becomes very, very important, particularly our autonomous tools for enhancing precision in things such as crop health management and disease diagnostics. Machinery, the incorporation of these tools helps. Of course, labor demands are a huge issue with particularly our small scale farmers. And so the incorporation, adoption of these technologies can help with the labor shortages that have been going on for quite such a time. And so by using these technologies, we're able to give information to farmers to help them with their data-driven decision making. We do a lot of outreach and extension, on-site crop health assessments and diagnostics for farmers, but also experiential learning. We want to actually have the hands-on experience with the farmers and allow them to learn and actually use these technologies in hopes they may want to adopt them. And so education becomes incredibly important as well. As we are working with farmers, we also work with the next generation of farmers, our students. And so in hopes that we can get them more interested in agriculture and help meet the demands of our society, which particularly is in global food security. And so, as I spoke about before, the data-driven decisions become so important. There's so much data that can be obtained from the use of these autonomous technologies that can actually inform the farmers on better crop production practices. Sustainability, we hope that the incorporation of these technologies will help them make their management practices more sustainable, leading into the future. Hope to reduce costs if possible, which is greatly needed for our small scale farmers. So we provide access to advanced technology. We try to level the playing field by providing these small scale farmers with cutting edge tools. And you can see down at the bottom, I have a couple of my work study students directly in the middle. And on the periphery, on the left side, we see Mr. Hooks. And I'll talk a little bit about a case study where our students and we just came back on Sunday from doing a crop health assessment for Mr. Hooks. And I will talk about later in this presentation some of the activities that we're doing. On the very right side is his son, Demetrius, who is a 4th generational farmer right here in Shorter, Alabama. And so it becomes important for reaching both generations, multiple generations, and providing them with access to these modern precision farming technologies. So we hope to improve productivity, enhance the crop performance and yield, and contribute to food security. And that's what technology is primarily developed for, is to help make things better, to help grant access to people that may not have access to them before, and to help, in this case, make crop production more sustainable. Talked about the educational benefits, the experiential learning, going to the farmers' fields, actually training them in the use of these tools, training the next generation of students becomes incredibly important for sustainable agriculture. And so we do not do this alone at Tuskegee. We are proud to collaborate with many partners, particularly with our colleagues at the University of Illinois, many as you see here. And so I am involved with many projects, such as the iFarm project, such as the AI Farms project, where at Tuskegee, we are developing an AI microsite similar to the efforts that are going on at the University of Illinois, in hopes that we can enhance our research and teaching and extension infrastructure. So plant phenomics. Plant phenotyping involves the studying of plant traits, whether it could be things such as stem height, the number of fruits that are produced. I work a lot with sweet potatoes and peanuts. And so with sweet potato, we look at things such as the flesh color, the nutritional content, the skin color, morphological differences, these different traits, and to help us distinguish different breeds of plants, but also to distinguish things such as the emergence and progression and symptoms of disease. I have students now who are engaged in AI modeling of plant diseases, and also AI modeling of different plant breeds based on their leaf morphology. So automation becomes very, very important, particularly in plant phenomics, to accurately detect and be able to identify different and important traits and characteristics that are unique to breeds. So plant phenotyping becomes very, very important for areas such as crop improvement, when researchers develop new cultivars, where we need to rapidly and effectively screen them for any different or unique phenotypic traits that may be indicative of the species. And also, when performing routine analysis, such as subjecting different cultivars to be resistant and susceptible cultivars to pests, we need to be able to rapidly and accurately detect changes, physiological and phenotypic changes that may occur, and help distinguish our resistant and susceptible cultivars, adding into the hopeful release of these cultivars for agricultural production. So automation and crop phenotyping. We hope to overcome the limitations of manual phenotyping. I come from a semi-farming background where my father has done a lot of farming, and as I grew up, myself, my brother, and my sister, we did a lot of work outside. And so one of the things my dad used to talk about was walking the back 40. And so this is a phrase that many farmers have probably heard before. And it details going out and actually checking the 40 acres of land, or however many acres of land one may possess, and then checking for diseases or nutritional needs, or other, just a complete evaluation of the field and the crop yields. And so automation becomes very, very important in providing more efficiency in crop phenotyping and crop health diagnostics. Instead of having to spend the time of walking through many rows and many acres of fields, well, we can deploy vehicles such as unmanned aerial vehicles, or drones, or terrestrial rovers that are equipped with cameras and other sensors that can rapidly detect and provide information on the plant health status. This becomes incredibly informative for farmers so that they can make the best decisions in order to enhance and sustain their agricultural crop productivity. On the right-hand side, we can see a terrestrial rover that the University of Texas is actually employing now for automated plant phenotyping. So this particular rover has been equipped with many, many different sensors and many technologies such as cameras in order to rapidly assess the crop health status. Outreach and extension is a priority. It's one of our mission statements here at Tuskegee University. So bridging the technology gap to small scale and minority farmers is not only my work that is assigned, but it's something that I believe very deeply about. I talked about Al Hook's produce. Down at the bottom, you can see that I've actually provided demonstrations for a diverse group of stakeholders and participants. At the bottom, we can see that this is representatives from the mayor's office in the city, from the city of Dothan, Alabama, who came and visited Tuskegee and wanted to learn about some of the autonomous robotic technologies that we are now integrating into our research and extension. And so with this, I provide them, of course, with the experiential training in the use of our drones. On the right-hand side, we were very pleased to have Dennis Bowman, an extension specialist at the University of Illinois, to actually come to Tuskegee during our Small Farmers Conference and actually provide awareness and also opportunities for the use of these different unmanned aerial vehicles. As you see, the one at the bottom that he's actually displaying actually is equipped with a sprayer. And so we're very happy to have Dr. Issa Salah and, of course, Dennis Bowman visit us during our Small Farmers Conference and actually talk about these different technologies and provide awareness for them. Here you can see that I have our automated greenhouse that we are developing that consists of many sensors and, of course, a FarmBot, which is an automated plant phenotyping tool. And so I'm giving presentations to some of our university students, some visiting stakeholders. And on the very left, you see a farmer who happened to come along with the students. And so it was a great pleasure to meet with him and actually talk with him about some of the initiatives that we have with extension with farmers, particularly outreach and providing free services for them, which I'll talk about towards the end of this webinar. On the right-hand side, do a lot of professional meetings where I'll take different autonomous technologies and bring them to meetings such as the National Black Growers Council meeting. And so that we provide them with awareness, we make networking and contacts so that we can identify people, stakeholders, producers that are interested in learning how to use and adopt these technologies. On the left-hand side, this is Mr. John here in Selma, Alabama. And so we recently, myself and one of our former extension agents, who's now a PhD student at the University of Illinois, John Myers, we actually went to his farm and we performed a free crop health assessment and taught him how to use one of our drones for crop phenotyping. On the right-hand side, we have Mr. Johnson. And so he actually is an animal producer. And so even with that, our students are now developing ways of monitoring its animals. And at Tuskegee, we are now developing AI models for things such as reproductive management, particularly in goats. And so we hope to deploy and develop technologies and AI-based models that can help farmers not only in crop production, but also moving towards animal production as well. And so a short article that I wrote recently talked about the use of autonomous robots to address labor demands and improve efficacy in agriculture. And so this was important not only to get this information out to the public and disseminate this knowledge, which is also one of our mission statements at Tuskegee, but it also, as you can see here, gave an opportunity for our undergrad students and work study students to be published in an article. And so even before the onset of COVID-19, there's been a large constraint in the availability of labor. And so how do we address the shortage of labor, particularly post-COVID and moving forward? And so the adoption and the integration of these autonomous technologies becomes so very, very important for addressing the labor demand so that we keep our country moving forward and keep our agriculture sustainable. And so one of the projects that I'm very excited to work on is a project that's headed by Dr. Girish Krishnan, and of course, Dr. Naveen Upalapati, Dr. Girish Chauhabri, and Dr. Atala, and Dr. Athi on the Robotics Integrated High Tunnels project. So this project involves the use of a multifunctional robot. And so it becomes very important for urban farmers, particularly our target would be urban farmers that are using a hoop-based propagation systems or your tunnel houses. And so as we move to the next slide, you can see in this video one of the robots that has been developed at the University of Illinois. And this particular robot is now being developed for harvesting, particularly cherry tomatoes. And we hope to deploy this, of course, under hoop houses, but also other field conditions as well. And so with our project with University of Illinois, we at Tuskegee will be receiving one of our own phenotyping robots. Now, this particular terrestrial rover, as you see by graduate students Puvan and Puyan on the right, has been developed to actually identify the Japanese beetle. And so the Japanese beetle is a serious constraint, a serious pest that causes millions of dollars in disease and damage each year, particularly on soybean and corn, which is, of course, one of the major crops that are grown in the state of Illinois. And so this particular terrestrial rover is equipped with a camera and an AI model for Japanese beetle detection, but also can be equipped with a sprayer. And so we at Tuskegee are now are partnering with the University of Illinois to develop some AI modeling, some object detection and AI models for detecting different pests, but also being able to deploy pesticides on demand and on site directly when the pest is detected. And so this becomes very, very important for efficiency in farming, saving costs on the amount of pesticides that are actually being deployed during farming practices. Well, this becomes equally important in reducing the amount of chemicals that are actually released into our environment. And so all under the umbrella of precision farming. And so the iFarm, Illinois Farming Regenerative Test Bed, another project that we are very happy to work on with Dr. Chauhabri and others involved in this project, including Dr. Salah. This project on our end in Tuskegee specifically points to integrating and providing awareness and promoting adoption of autonomous robots for our small scale and minority farmers. And so we have been working with EarthSense, and I'll talk in a few minutes about some of the robots that we are using from EarthSense in crop phenotyping and providing crop health assessments, and also using these for experiential training with our farmers, producers, and stakeholders. And as you can see here, our outreach and engagement each year, as I spoke about previously, we entertain many producers and stakeholders from all over the country. We invite them in here to Tuskegee during our Farmers Day, and you can see Mr. Bowman and Dr. Salah here on the very left, next to one of my work study student, and how they actually brought some of their cover cropping technologies from EarthSense, and we introduced them to some of the terrestrial rovers. And so it was very impactful to see the interest in the farmers in these technologies. And we have actually developed other projects that provide credits, actually financial incentives for farmers that join these cover cropping projects, And so that becomes very, very important to to increase interest in these technologies and our programs that are targeted to help and benefit our farmers and producers. On the right-hand side is our most recent farmers conference, and it was raining outside, so the participation, the amount of participants was a little bit lower than previous years, but still, we were able to give them an engaging session and talk to them about their concerns and address their needs for things such as labor shortages and crop production enhancement and improvement. So recently in September, I was asked by Dr. Pomaku, one of our esteemed scientists here at Tuskegee, to participate in the Cochrane Fellowship Program. So Dr. Pomaku received a USDA Cochrane Fellowship named after the late U.S. Senator William Thad Cochrane. And this fellowship actually provides training opportunities for agricultural professionals all over the world at an international basis. And so we had producers, farmers, and stakeholders from places such as Jamaica, Costa Rica, Dominican Republic, and other places visit Tuskegee. And I was happy to engage them and introduce them to some of the technologies that are being used for crop phenotyping and in agricultural production. At the bottom, you can see our FarmBot. And so with the AI Farms grant that was received with our collaboration with the University of Illinois, one of the first robotic technologies that we've integrated into our greenhouse here at Tuskegee University is the FarmBot. And the FarmBot is a automated plant propagation tool. As you can see towards the bottom, this plant is actually in the process of running a watering sequence. And so our students have been trained to actually program this robot based on the positions of the plants within the wooden frame you see at the bottom. So these are different cultivars of sweet potato. At Tuskegee, we are mandated to work on sweet potato and, of course, peanut due to the legacy of George Washington Carver. On the first screen, I did not mention, I should have definitely mentioned George Washington Carver and his impact he's done on Tuskegee University, but also in agriculture. And Mr. Jim Baltz, actually, he added the Jessup wagon, which really is the model for extension and outreach. So this is the Jessup wagon that you see here on the right-hand side. And so this is how George Washington Carver was able to take new technologies. He did a lot of innovations with crops, building plant-based plastics, which I actually used in my botany lab this week and introduced that to the class. And of course, the innovation he's done with peanut. And so getting this information out to the farmers in the local community was very, very important. So the use of the Jessup wagon definitely enhances outreach and extension efforts. So moving back to some of the case studies here. So this is the Terrasentia. This is a terrestrial crop phenotyping robot that has been developed by the company EarthSense, who are led by Dr. Chinmay Soman and Dr. Girish Chaudhary. And so the Terrasentia is a compact field robot designed for plant phenotyping. As you can see here on the right, it has a LiDAR, so it can generate 3D images. You can see that it's now been trained to look at plant traits such as stem width, and also it has object detection for counting the things such as soybean pods. And so there's so many different traits that have been programmed for detection in this robot. So it becomes extremely useful for crop phenotyping at the terrestrial level, at the field level. The rover is equipped with cameras in the front, the top, and on both sides, and also a GPS for positioning in the field. It can be trained for autonomous motion. And so with the proper field settings that are inputted into the software, the rover will be able to move through the rows while it's collecting numerous amounts of data and turn around at the end of the rows and continue until the mission is complete. And so it measures plant height, biomass, canopy cover, things such as leaf area index, a lot of important plant traits that can help indicate the plant health status. It is pretty lightweight and portable and very high accuracy for close proximity measurements. This is just another photo of one of our first multispectral drones. And of course, we have my fraternity brother's daughter here who's piloting it. And so we have a lot of STEM days and training days, outreach days for K through 12 and for prospective students where we engage them in these technologies. We want to let students know that agriculture is becoming extremely advanced now. We're moving on from our traditional cow and plow and moving into more automation. And so that helps to attract a wide, diverse audience of students, those that may be interested in computer science, engineering, and others. And so moving into another case study, the use of unmanned aerial vehicles as what we all know as our drones. And so these drones are incredibly important for rapid and efficient crop phenotyping and plant health assessments. And they can be equipped with multispectral or hyperspectral sensors that can relay and capture a tremendous amount of information that we can use to analyze the plant health status. And so how we use the drones, as the drones are flying over the field and they are taking information, they're taking images, sometimes 500, 600 to over 1,000 images. Well, we can stitch those images together to create what's called an orthomosaic, which is a complete representation of all of the field site. And so how do we use this information? Well, the multispectral camera is so important because as we know that there are multiple wavelengths of light that is being projected or emitted from the sun. Plants absorb red and blue light through their chlorophyll pigment molecule, which of course triggers the process of photosynthesis. And plants reflect green light, which is why plants appear to be green. And so the multispectral camera is able to capture multiple wavelengths of light and reflectance of these wavelengths of light, as well as, and the absorptions can be analyzed through different software. And so there are vegetative indices, many different vegetative indices that can be useful for taking this drone collected data, taking the images, the multispectral images, and actually analyzing them and providing an informative output. As we see on the left-hand side, we see healthy versus stressed plants. Now, how do we use this information to determine their health status? Well, the vegetative index, such as the normalized difference vegetative index, or NDVI, is based on an equation that looks at the near infrared spectrum of light minus the red wavelength spectrum of light divided by the near infrared spectrum plus the red spectrum of light. And so this equation is actually useful for developing this index, which has a score that ranges from -1 to 1. And so based on the scores that we get from these indices, such as the NDVI, we can accurately detect how well the plant is performing based on its biomass production. As we can see, from -1 to 0, if we receive an NDVI score of -1 to 0, we know there's probably no plants that are present in the soil, or if so, the plants are most likely dead because they are not reflecting green light. And of course, they're not absorbing a lot of red and blue light due to the absence of the chlorophyll molecule. And as we move up the range of index values from 0 to 0.33 to 0.66 and all the way up to the number to 1, we can see, based on the reflectance of green light and the absorptions of red and blue light and the interaction of near infrared and red wavelengths of light, we can determine the health, how robust the plants are growing based on these numerical values. And so recently, my students and I went out to the Hooks Farm in Shorter, Alabama, and we provided a free crop health assessment using our unmanned aerial vehicles, our drones. And so on the right-hand side, Mr. Hooks here, this is actually a field of rutabaga, not collards. And so I just wanted to make sure I clarify that for all the plant breeders and researchers here that are listening. So as you can see at the top, we use the drone to take many pictures and of course, the multispectral drone to take many pictures of the field, and I had my students use software to compile those photos into one complete orthomosaic of the Hooks rutabaga field. And from that, we employ the NDVI analysis using our software. And so from the software, I modified the NDVI equation to reduce the amount of soil and really concentrate on the rutabaga plants themselves. And I had one of my students, Alasia, to provide annotations to annotate these different rutabagas so that we can actually determine NDVI values for each of the plants within the field. And so from this, as you can see, most of the rutabagas that actually are grown have an average NDVI of around 0.75. So if we go back to our index value score, 0.75 definitely falls into the range of a very healthy plant. So that becomes very informative for the farmers as we provide these reports to them. But also, if you look at plant number 15 and plant number 16, you can notice that there is a slight drop in the NDVI score. So this really helps us with precision farming. And so we did another mission, a drone mission this past Sunday, and my students are analyzing the data now. We want to check and see if plant 15 and 16, if their NDVI scores have improved or have worsened, because this now will become a hotspot within the field that would need attention. So the precision farming, we can now inform the farmers where they need to apply maybe fertilizer or pesticide based on the status of the plant. So that saves time and it saves money with the deployment of chemicals or materials that are useful for improving the plant's health condition. So we're able to pinpoint areas in the field of great interest. So my students at the bottom, as you can see, we want to not only use automation, but we also still want to use manual ground to truth data collection, things such as measuring plant height manually, using chlorophyll meters to actually measure chlorophyll content, and using these manual ground to truth data with the data from our autonomous tools. This becomes important for a very robust and comprehensive assessment of the plant health status within the field. On the right-hand side, you see this is a farmer that I met at the Tuskegee Farmers Market who's very interested in us providing these services for his field as well. So I'm talking with my students now, and we are hoping to get out to his farm and provide some free crop health assessments for him as soon as possible. So the cooperative extension with Tuskegee, it becomes so important with collaborating with them so that we can establish and gain access to the network of farmers in our surrounding communities, so that we can not only meet with them, but we want to hear and address their concerns, so that we can start to align our research efforts based on the concerns and the needs of our local farmers. As you can see here at the farmers market, there is a great place to not only buy some incredibly delicious foods, and support our minority and small scale farmers, but also to network and make contacts with them through our cooperative extension network. Here we have Dr. Jessica Wiedow, who is the executive director of the AI Farms project. And so this summer, I had the privilege of, I was awarded a USDA sabbatical grant with Dr. Elizabeth Ainsworth, who is a highly regarded plant researcher in agriculture. And so I spent a couple of minutes showing Jessica how to fly, and of course the drone. So now she's an official, or I'll say unofficial drone pilot. And what's very interesting, as you see down at the bottom, she brought her co-pilot, Olive, her very engaging and very happy dog. I've never seen a dog smile before like this. So And so it was particularly doing field work. And so it was great to have Jessica engage with us and bring Olive out to the field and to assist in our crop phenotyping efforts for our project, which involved phenotyping of newly bred and newly crossed soybean cultivars. And so moving forward, we have just submitted a requisition, and we hope to integrate a new farming tractor robot, the Amiga, by the company FarmNG. And so this multifunctional tractor robot, as you can see here, can be integrated and equipped with many different devices for things such as tilling and plowing, but also, as you can see on the left-hand side, it has an onboard computer. Now, the computer actually has a Python interface. And so the goal is for us to develop AI models and programs that we can integrate into the tractor robot. So as it moves through the field, it can collect data. It has cameras that have been equipped with it, and we can develop AI models and programs for things such as plant disease detection. Our colleagues at the University of Illinois have this Amiga tractor already, and they've already developed AI models for horseradish production, for weed management in horseradish production, which is a niche production area, particularly in the state of Illinois. And so we're going to work with them, of course, with developing our own AI models for things such as plant disease detection and other important plant health assessments, so that we can increase our research infrastructure here at Tuskegee, but also deploy these, add these into our tools used for crop health assessments for our small scale and minority farmers in the community. So empowering the next generation of agriculture, so incredibly important. Almost every year I'm involved with summer programs where we have high school and undergraduate students and even elementary students come to campus, and we provide them with experiential learning activities. Last summer, I was very pleased to have 3 young ladies to visit my lab, and I worked with them on testing out a very novel protein that has an incredible antimicrobial properties. And so this was developed by one of our esteemed researchers and protein guru, Dr. Jesse James. And so the students tested the protein out against nematodes, which is one of my primary pathogens that I study, the root knot nematode, and saw it had incredible efficacy in managing the nematode. On the right-hand side, the first student on the right-hand side next to the poster is Elena Bell. Elena is a high school student in Ohio. And so she wanted to continue our research back at her high school. So Dr. James and I shipped her some of the peptide, and she showed that the peptide is equally effective against the soybean cyst nematode, which is a major issue in agricultural production, along with the root knot nematodes. And of course, plant parasitic nematodes in general cost billions of dollars in crop losses each year. And so we're very pleased to work with Elena. She's actually won first place, $1,000 in a science fair competition. And the Ohio Soybean Council is very interested in her work now. And so she's emailed us back recently wanting to move into CRISPR and gene editing for soybean crop improvement. And this is one of our visiting community college students came to Tuskegee, and I provide them with experiential learning with the use of our rovers and use of our drones. And we talked about the state of agriculture and the importance of a multidisciplinary approach. A lot of these students, some of these students want to be computer software engineers. Some of them want to be mechanical, electrical engineers. So we talked about how diversified agriculture is and how their majors can be applied in agriculture. And actually, they can use agriculture to better develop their majors. And so this becomes so important of inspiring the next generation so that we can replenish our agricultural workforce with highly trained and well-equipped students. Christian Peterson here, one of our recent PhD graduates, he has done a lot of great work with developing AI models for goat reproductive management. training AI models to detect goat tail positions, whether up or down, which is an indication of their estrus. And so this becomes very important for supporting goat reproductive health, particularly in confinement settings. And so using his approach, we have now developing a standard operating procedure to develop an AI model for plant health and disease detection, and also for plant phenotyping based on things such as leaf morphology, differences in leaf characteristics, and also for sweet potato, differences in peel and skin and periderm characteristics. And I want to thank Dr. Angela Green, and of course our Dean, Dean Bolton Taylor, for working with Christian Peterson, and Christian for actually training me on how to develop these AI models. And Dr. James Mungen now is taking over this particular aspect in goat research. These are some of my students here that are actually running the vegetative indice analysis from some of the data that we've collected. As Micah, they are on the laptop now, and our two of the twins that I work with, Cameron and Kaylin, and then of course Sade right there in the middle. So here we can see on the left-hand side, the young man you see is Milan James. He is the youngest certified hydroponic crop producer in the state of Georgia. He's about 14 years old. And so he wanted to come out to the field with one of our Tuskegee professors on the left to visit and to learn about some of the automated technologies that we're using. So he very easily learned how to develop a sequence for watering our sweet potato plants, as you can see here, and deploying it. And also he was trained on the use of drones. So he's very excited. His TikTok is crazy. He has so much support from so many people. And I hope he will to continue to work with him. And I'm excited to see how he's going to progress in his future endeavors. In the middle and on the right-hand side, Micah, they were running the terrestrial rover through the field and collecting data at a local blueberry farm. And so a lot of our Tuskegee students had an outreach day where they went out to the blueberry farm. And of course, they were helping with field maintenance, cleaning up the farm. And so I decided to bring Micah to do some crop phenotyping. And I also bought a gallon of the blueberry juice, which was $30. And so I took my time sipping this blueberry juice very slowly to preserve it as much as possible. And I have to tell you, I've never had blueberry juice taste as good as what I've tasted fresh off their farm right here in Tuskegee, Alabama. And so I have recently developed a initiative to increase our crop health assessment engagements with local and minority small-scale farmers using the autonomous robots. And so we are now promoting this flyer out in the community. I'm looking to speak with a radio personality to get on air time for more advertising, so that we can get these projects, the iFarm project, our urban tunnel project, the projects we have with Illinois, the projects we have with Tuskegee, all of them have cross-cutting themes. And so the main theme, of course, is promoting the use of these autonomous tools and providing crop health assessments and diagnostics for farmers for free, and also providing them with the experiential training on the use of these technologies in case that they want to adopt these technologies into their production protocols. And with this, I will kindly ask Dr. Salah to speak a little bit about the iFarm Farm of the Future slide.
Thank you very much, Dr. Gregory. Really, I always enjoy hearing from you and seeing all the great work that you're doing in Tuskegee University. And just to let our audience know, you can check out our website at i/farm.illinois.edu, or go to go.illinois.edu/ifarm updates if you want more updates on the great progress that we're doing every year at iFarm. And now Todd with the sponsorships.
Hey, thank you very much. Salah is, of course, is in the College of Agricultural, Consumer, and Environmental Sciences here on campus in agricultural and biological engineering. We appreciate his participation today and thank Gregory Bernard from Tuskegee University for being with us, as well as our sponsors. By the way, while I'm talking about them, if you've got questions, drop them into the question box. We'll get them answered here in just a moment. Our sponsors include the TIA Center for Farmland Research, CoBank, Compeer Financial, Corteva AgriScience, Farm Credit Illinois, Growmark, the Illinois Corn Growers Association, and the Illinois Soybean Association, which reminds me, because Dr. Bernard talked a little bit about the soybean cyst nematode in Ohio, that here in Illinois, you can send your soil samples, if you'd like, from those soybean fields to the plant clinic, and they will run a free analysis for nematodes. So that comes courtesy of the Illinois Soybean Association. And then the educational partners for us on the next slide include the Farm Doc educational partners like the college here, the Agricultural College, ACES, along with the Department of Agricultural and Consumer Economics, University of Illinois Extension, the Gardner Agricultural Policy Program, and the FBFM. That's the Farm Business Farm Management Unit across the state of Illinois. That is a record-keeping system that the Ag Economist tap for much of the work that they do in the outreach that comes from the Farm Doc Daily website at farmdocdaily.illinois.edu. We'd also like to thank you for being here for the day and remind you there are a couple of things, including the Farm Doc Daily website on the next slide at illinois.edu and the youtube.com website at youtube.com/@FarmDoc. Again, if you have questions, drop them into the website or into the GoToWebinar control panel. I do have a couple of questions for you, Dr. Bernard. I was interested up front in wanting to know how the automated phenotyping works, the one that runs through the field, particularly what the sensors and cameras are looking for on those plants as they rove through the field, and why that's useful.
Very good. Thank you for the question. I'm going to move back to slide. So the terrestrial rover, as you see, has cameras on the front, left, right, and top. And so as it's moving through the field, it's taking pictures of the plants. Now, the developers have integrated object detection models within the rover. And so the bounding boxes that you see later actually is part of the object detection. Here you can see LiDAR, where it develops a 3D model of a plant. And so you can see now that some of the traits such as stem width, plant height is being detected as the rover is moving through the field. It's counting the number of soybean pods as it's moving through the field as well. So this provides a lot of useful information of plant characteristics and how they may be affected by, let's say, a change in fertilizer, maybe the presence of disease, just an overall evaluation of the plant health status at any given time becomes very, very important. There's other traits, plant traits, that have been integrated into the software for this rover. And so you can actually, when you plan your mission, you can specifically target what traits you want to look at. You can also develop your mission based on the status of the plant, whether it's a seedling or it's more advanced growth. And so the rover is able to make those adjustments as it's moving through the field. And so a lot of information that's taken. As I said before, the LiDAR that's equipped on the rover takes the images and makes the 3D models for other assessments. And then, of course, the GPS that it has on the back for better global positioning. So as the rover is moving through the field, it's collecting so much data, and the people at EarthSense, we can upload the data directly to them for analysis. And so that becomes very, very important. That saves a little time as we can move on to and do so many of the other analysis that we have to do here. And so I hope that answered your question.
It does. A second question, this one about the high tunnel robots. How do the high tunnels need to be adapted for the robotic integration? And by that, I mean, what needs to be done within the high tunnel to accommodate that robot? Do you have to have wider aisles, for instance, lower tables, work areas, or shelvings that are different? And This one, of course, is inside a building. But once you're out into an actual high tunnel, do other things need to take place?
That's a great question. So that's one of the things that we're going to analyze and actually determine as we deploy these robots. And so part of the mission is, particularly on our side here at Tuskegee, we have to take a survey first of farmers that have tunnel houses that will be interested in adopting these technologies. So that's part of our project. Number two is training of the rover, not only for myself and other faculty, but for students as well. And so part of that survey, and of course, we would develop educational, experiential training modules for students, participants, and stakeholders. So part of that survey will be outreach efforts where we will actually go out and visit the tunnel houses, and we can assess how well the rovers actually work in their tunnel houses. So over time, as we collect more and more data, and we visit more farmers, and we position and test the rover within the tunnel houses, we can get a better idea of a baseline of the row spaces and all of the intricacies of the tunnel houses to make an efficient mission for the rover. And so your question, it's a great question. So at this time, I would say that we are still developing ways to determine what would be the best situation to deploy this type of rover efficiently.
And as we close out our time together, if you can pull that last slide up saying thank you to the folks that are here. We do appreciate everybody being along. You've been listening to a FarmDoc webinar, this one titled Bridging the Gap, Technology Adoption in Smallholder Farms. Our guest today has been Gregory Bernard. He's at Tuskegee University in Tuskegee, Alabama. That's located between Montgomery and Atlanta. We thank him for being here, along with Salah Issa from the University of Illinois and the Department of Agricultural and Biological Engineering in the College of Aces, along with Jim Baltz, who's behind the scenes, our technical director for the day. You have a good afternoon. I'm University of Illinois Extension's Todd Gleason.
Thank you all, and thank you, Jim Baltz, for your work with this impressive PowerPoint.